If you could press an X-ray button and watch your skeleton move in real time, what your shoulder blade does when you raise your arm would look less like a simple body position and more like a coordinated engineering system. In this video, we are going to look through the outer body and follow the bones underneath because the skeleton often explains the movement better than the surface does. This is for general education only, not medical advice, and it is not meant to diagnose pain, injury, or any medical condition. The main idea is simple. Bones do not move alone. They move as linked segments, with one part changing the path of the next. For scapulohumeral rhythm, the important structures are scapula, clavicle, humerus, shoulder socket. Imagine the skeleton as a set of connected levers. When one lever tips, rotates, or shifts, the nearby joints have to respond. That response can make movement feel smooth, stable, powerful, or sometimes awkward.
On the outside, the human body can make movement look soft and simple. But when the body fades into an X-ray view, you can see that the skeleton is constantly solving balance problems. The skull has to stay above the spine. The spine has to stack over the pelvis. The pelvis has to transfer force into the legs. The feet have to meet the ground and send that force back upward. This is why a small change in alignment can show up somewhere far away from where it started. The first key point is that the skeleton uses shape to guide motion. Joints are not loose hinges floating in space. They have curved surfaces, ridges, sockets, arches, and contact zones that nudge bones along certain paths. In what your shoulder blade does when you raise your arm, those shapes matter because they decide where force travels. A rounded surface may roll. A socket may center a bone. An arch may compress and rebound. A curve may spread load across a wider area instead of concentrating it in one spot. A useful analogy is a camera gimbal or a suspension bridge. The structure is not just holding still. It is constantly adjusting so the main load stays controlled. Your skeleton does something similar. The bones give the body a firm framework, but the framework is not rigid like a statue. It is more like a living machine with small controlled motions happening at many joints at once.
The second key point is that movement is usually a chain reaction. If the joint above changes position, the joint below often changes its path. If the base shifts, the upper body has to rebalance. This is why the X-ray view is useful. Instead of staring at one painful-looking or strange-looking area, we can watch the full chain. We can see how the bones line up, where the load is moving, and which structures are acting like the main bridge between regions. In real life, this shows up during simple actions like standing, walking, reaching, squatting, lifting, or looking down at a phone. From the outside, these actions can look ordinary. In the skeleton, they are full of small rotations and weight shifts. A few degrees of motion at the hip, spine, shoulder blade, ankle, or neck can change the line of force through the entire body. The third key point is that bones manage both motion and stability. That sounds contradictory, but it is the central trick of anatomy. The body needs enough movement to adapt, but enough stability to keep force from becoming chaotic. So the skeleton often uses paired motions. One bone rotates while another glides. One curve bends while another region counters it. One arch compresses while nearby joints stiffen just enough to help push off. A common mistake is to think there is one perfect skeletal position that always applies. In reality, the body is built for movement variety. The goal is not to freeze the skeleton into a single ideal pose. The more useful question is whether the bones can move through a comfortable range, share load across multiple joints, and return to balanced positions without one region doing all the work. Now look at the highlighted skeleton again. The bright region is the main area for this video, but the dimmer bones around it are just as important. They are the supporting cast. When the highlighted area moves, the surrounding skeleton changes the background conditions. That is why anatomy is easiest to understand when you can see both the close-up structure and the whole body X-ray view at the same time. This does not mean every click, curve, shift, or asymmetry is automatically a problem. Human bodies are variable. Skeletons are not perfectly symmetrical machines. But understanding the mechanics gives you a better mental model. Instead of thinking something is randomly wrong, you can ask what bones are moving, what direction is the force going, and what other joints are part of the same chain.
So the recap is this. What your shoulder blade does when you raise your arm is really a skeleton story. The outer body gives us the shape, but the X-ray view shows the levers underneath. The important structures are scapula, clavicle, humerus, shoulder socket. They guide motion, share force, and connect one region of the body to the next. If this kind of visual anatomy helps you understand the body more clearly, subscribe for more calm 3D body science explainers.
One more way to think about this is to follow the line of force through the skeleton, instead of only looking at the body part that gets your attention. In what your shoulder blade does when you raise your arm, the highlighted bones are scapula, clavicle, humerus, shoulder socket, but they are never acting by themselves. The skeleton is always answering three questions at once. Where is the weight? Where is the next movement going? And which joint has to guide the transition? When those questions line up, motion often looks smooth. When they do not line up, the movement may look stiff, rushed, or less coordinated. That does not automatically mean something is injured. It simply means the body is using a different strategy. The X-ray view also reminds us that anatomy is three-dimensional. A bone can tip forward, rotate, glide, compress, or act as a lever, and those motions can happen together. This is why a flat drawing can make the body seem simpler than it really is. With the skeleton visible inside the human outline, you can see how a small shift at one region creates a response above and below it. The useful lesson is not to memorize every bone name. The useful lesson is to see the body as a connected structure that balances mobility, stability, and load sharing in every ordinary movement.